Welcome to a lesson with Dr. Powell. Let's look at optimizing a surface or finding the smallest, the lowest point or the highest point on a surface. So we're going to look at an example and just kind of work slowly through it. We're going to have f of xy is equal to 5x squared minus 6xy plus 5y squared plus 16x minus 16y plus 16. Okay, so that's our function and that's our surface that we're going to be working with. All right, we want to find a low point or a high point on this. First of all, think about this. If you have a spot that's instantaneously level, then that means that the derivative, it's the derivative itself, thought of as kind of a function that goes from run to rise, is going to always give a rise of 0 if it's the derivative is right there at that point. So no matter what run you take from this point, the instantaneous idea will be to output a rise of 0. So we can expect, so if the derivative looks something like this, we can expect this guy right here, because no matter what we put in here, we want to be able to get 0. We can expect that both of these must be 0. So that's kind of how you get like critical points. You realize that if you're looking in the XY plane, you know, that you might have a graph that's instantaneously 0, right? But it might not be a max or min. However, when you do have maxes and mins, and assuming that the function is smooth, not cornered, then we naturally have this idea that fx and that the derivative is 0. And so similarly, we're going to think of the same thing here. Only we have a matrix now, but both components are going to be 0, because that's going to give us 0 rise for any run that we choose. Okay, so let's go for that. And we're going to take find the derivative of this, the first derivative of this function, and write it down as a matrix. And it's going to be, okay, so first we find, so remember, find the partial with respect to x and the partial with respect to y. Okay, so with respect to x, let's see, we're going to get, we're going to get 10x and then minus 6y, because we're treating y as constant. That's a constant, so it's gone, plus 16. And then all that's constant, so that's gone. For fy, let's see, that's constant, so that's gone with y as the variable, so we get minus 6x, and then we have plus 10y, and it's constant, so it's gone, minus 16. Okay, so this is our first derivative, and we'd like this to be 0. So that means we have a kind of a system of two equations. We want that 0, we want that 0. Okay, so working with that, we could put these down here and just kind of solve that out and see where we're going to be looking. All right, minus 6x plus 10y minus 16. So there's various ways of solving a system of equations. Here, I think what we'll do is, well, first of all, let's just divide everything by 2. So yeah, so 5x minus 3y plus 8 is equal to 0, and minus 3x plus 5y minus 8 is equal to 0. Now, I'm just going to multiply the top equation by 3. Yeah, let's do that. That's fine. Top equation by 3, the bottom equation by 5, and then just add, because you notice you get 15 and minus 15, and that'll cancel out your x's, so you only have y's. And the y's, you're going to have negative 9y and 25y, which would give you 16y. And then since you're, 16i, see, is that right? Yes. So minus 9 and 16 And I'm just double checking my results. Yes, okay. And so 16y. Oh, okay, then we multiply. That's right. 3 times 8 and 5 times that. Okay, so that would give you, it's like 3 minus 5, which is minus 2 times 8. So minus 16, I believe. Minus 16 is what you get. Okay, and so that's equal to 0, so we can solve it. Y is going to be equal to 1. Okay, so with y being 1, we can throw that back in here and see what x is going to be. So y is 1, that'll make minus 6, so 16 will give you just 10. So plus 10, moving on this other side, negative 10, divide by 10, so x will be equal to negative 1. Okay, so we actually, and this looks like it's the only point that guarantees it. So it's our only critical point, just to check. We don't know if it's a maximum. We just know that the function is instantaneously leveling out right there. So we're going to give it we're going to say it's negative 1 and 1, and that is our critical point. All we need to do now is check it. We want to check to see if this function, even though it's leveling out there, I mean, is it a max or a min? So is it a min or is it a max, or is it just something kind of a level off thing? So what is it? And we'll address that in the next video. So we'll continue this example. Thanks for watching.